Have you ever wondered what the most valuable natural substances on Earth really are? Most people immediately think of gold. For thousands of years, it has symbolized wealth, power, and prestige. But hidden beneath Earth's surface, created in the hearts of dying stars, or produced by some of nature's most dangerous creatures, there are materials whose value can dwarf that of gold. Some exist only in microscopic quantities. Others are nearly impossible to produce, while a few are so essential to modern technology that industries around the world compete for every gram. Today, we're counting down 7 incredible natural substances and materials worth more than gold, moving from astonishingly rare metals to substances that challenge our understanding of value itself. Before we begin, if you enjoy fascinating science, rare discoveries, and amazing facts from around the world, don't forget to like this video, subscribe to the channel, and turn on notifications so you never miss our next countdown. Now, let's begin. Number 7. Iridium. Imagine a metal so rare that much of what we find near Earth's surface didn't even originate here. Iridium is believed to have arrived on our planet aboard massive meteorites billions of years ago. Today, it remains one of the rarest naturally occurring metals in Earth's crust, estimated to exist at only about 0.0001 parts per million. Its appearance is surprisingly modest, a silvery white metal with an almost understated elegance, but its physical properties are extraordinary. Iridium resists corrosion better than almost any other metal known to science. It tolerates temperatures exceeding 2400 degrees Celsius, making it indispensable wherever extreme heat and chemical resistance are required. Because of these characteristics, iridium plays a critical role in aerospace engineering, high-performance spark plugs, specialized laboratory equipment, and electrical components that must operate reliably for decades. Its scientific significance is equally remarkable. A thin layer of iridium-rich clay found around the globe helped scientists solve one of Earth's greatest mysteries, the extinction of the dinosaurs. Since iridium is far more abundant in meteorites than in Earth's crust, that unusual layer became powerful evidence that a massive asteroid impact occurred roughly 66 million years ago. Modern production remains extremely limited because iridium is almost never mined directly. Instead, it is recovered as a byproduct during platinum and nickel mining, with global production measured in only a few tons each year. Depending on market conditions, prices can range from around $1,000 to well over $6,000 per ounce, making iridium one of the world's most valuable precious metals. Sometimes, the greatest treasures are gifts from outer space. Number 6. Antimatter. Now we're leaving the world of rare metals and stepping into one of physics' greatest mysteries. Antimatter is unlike anything most people have ever imagined. Every ordinary particle has an antimatter counterpart with the same mass but the opposite electrical charge. When matter and antimatter collide, they annihilate each other completely, converting nearly all of their mass into pure energy, according to Einstein's famous equation, E equals mc squared. Nature creates tiny amounts of antimatter through cosmic rays, radioactive decay, and even lightning strikes. However, these quantities disappear almost instantly. Scientists can manufacture antimatter inside advanced particle accelerators, such as those operated by CERN, but the process is unimaginably expensive. NASA has estimated that producing just 1 gram could theoretically cost around $62.5 trillion, making antimatter the most expensive substance humanity has ever attempted to create. Even storing it presents enormous challenges. Antimatter cannot touch ordinary matter. If it does, it instantly vanishes in a burst of energy. Instead, researchers suspend it inside sophisticated magnetic traps within near-perfect vacuums. Although production is incredibly limited, antimatter already has practical applications. Positrons, the antimatter equivalent of electrons, are widely used in PET scans that help doctors detect diseases and monitor organ function with remarkable precision. Beyond medicine, antimatter continues to help physicists investigate some of the deepest questions about how the universe was formed and why matter dominates over antimatter today. It may never become an everyday material, but it remains one of the most fascinating examples of how valuable scientific knowledge can be. Number 5. Californium-252. Some substances are expensive because they're beautiful. Others are valuable because they perform tasks that almost nothing else can. Californium-252 belongs firmly in the second category. First synthesized in 1950 by researchers at the University of California, Berkeley, this highly radioactive isotope emits an enormous number of neutrons through spontaneous fission. One single gram releases roughly 170 million neutrons every minute. That incredible property makes Californium-252 exceptionally useful despite its rarity. Scientists use it in neutron activation analysis, allowing them to identify trace elements with remarkable precision. Mining companies rely on it to locate underground deposits of gold, silver, and other valuable minerals. The oil industry also uses it to analyze rock formations deep below Earth's surface. Unlike naturally occurring precious metals, Californium-252 cannot simply be mined. It must be produced inside specialized nuclear reactors over many months through carefully controlled nuclear reactions. Only a handful of facilities worldwide possess the expertise and infrastructure needed to manufacture it. Production is incredibly slow, and its half-life of only 2.6 years means every sample gradually loses half of its radioactive material over time. Its price reflects those extraordinary challenges. A single gram can be worth approximately $27 million, placing it among the most valuable materials ever produced. Despite its cost, governments, research institutions, and specialized industries continue to depend on Californium-252 because no practical substitute offers the same combination of capabilities. Number 4. Tritium hydrogen is the most abundant element in the universe. But one rare version of hydrogen has become one of the world's most valuable nuclear materials. Meet tritium. Unlike ordinary hydrogen, which contains only a single proton, tritium also carries 2 neutrons, making it radioactive and exceptionally uncommon in nature. Only tiny quantities form naturally each year as cosmic rays interact with Earth's atmosphere. Almost every usable gram is produced inside nuclear reactors. One of tritium's most recognizable features is its ability to create continuous light. As it decays, it emits low-energy beta particles that excite special phosphorescent coatings, producing a steady glow without requiring batteries or electricity. That's why tritium is commonly used in emergency exit signs, military equipment, aviation instruments, and premium watch dials that remain visible throughout the night. The glow can last for nearly 2 decades. Although radioactive, tritium emits particles so weak they cannot penetrate human skin, making properly sealed devices remarkably safe for everyday use. Yet its greatest importance may lie in humanity's future. Tritium is one of the primary fuels being studied for nuclear fusion, the same process that powers our sun. Projects like ITER hope to combine tritium with deuterium to generate enormous amounts of clean energy while producing far less long-term radioactive waste than conventional nuclear reactors. Because production remains tightly controlled by only a few countries, each gram carries tremendous strategic and scientific value. Today, tritium can sell for roughly $30,000 per gram, but its true worth may eventually be measured by the role it plays in solving the world's energy challenges. Number 3. Scorpion venom. At first glance, scorpion venom seems like something people would gladly avoid. Yet inside this deadly cocktail of proteins and peptides may lie the foundation for tomorrow's life-saving medicines. Some of the world's most valuable venom comes from the infamous deathstalker scorpion. Its venom contains highly specialized molecules that evolved to attack the nervous systems of prey with incredible precision. Researchers quickly realized that those same molecules might be useful in medicine. One remarkable compound, known as chlorotoxin, has shown the ability to bind selectively to certain cancer cells. Scientists have used modified versions of this molecule to create fluorescent imaging agents that help surgeons identify the exact boundaries of brain tumors during surgery. Other venom compounds are being investigated for possible treatments targeting autoimmune disorders, neurological diseases, chronic pain, and cardiovascular conditions. Obtaining the venom, however, is an incredibly slow process. Each scorpion produces only microscopic amounts. Specialists carefully stimulate the animals to release venom droplets without causing permanent harm, and each collection yields only a fraction of a milliliter. Thousands of extractions may be required to gather enough raw venom for scientific research. Afterward, the venom must undergo complex purification before researchers can isolate individual compounds for pharmaceutical testing. Depending on species, purity, and intended use, scorpion venom has been valued anywhere from thousands of dollars to several $1 million per liter. It is a powerful reminder that nature often hides extraordinary medical potential inside its most dangerous creations. Number 2. Diamond. Few natural materials have captured humanity's imagination like diamonds. Forged deep beneath Earth's surface, under crushing pressure and extreme temperatures, diamonds are composed entirely of carbon. Yet the unique arrangement of their atoms transforms one of the universe's most common elements into the hardest naturally occurring material on Earth. A diamond ranks 10 on the Mohs hardness scale, allowing it to cut virtually every other natural material. Its brilliance, durability, and remarkable thermal conductivity make it valuable far beyond the jewelry industry. Engineers use industrial diamonds for cutting, drilling, and precision manufacturing. Scientists increasingly rely on synthetic diamonds for advanced electronics, quantum technologies, and next-generation computing systems. Natural gem-quality diamonds remain exceptionally rare. Many formed more than 3 billion years ago, long before complex life appeared on Earth. Their value depends on the famous 4 C's: carat, color, clarity, and cut. Exceptional blue, pink, and red diamonds have sold for millions of dollars per carat, making them among the most valuable gemstones ever discovered. Although diamonds have become symbols of romance and luxury, they also represent one of nature's greatest engineering achievements. A crystal built, atom by atom, under conditions that few places in the universe can provide. Number 1. Rhodium. And finally, we arrive at the material that has repeatedly outperformed gold in market value: rhodium. This brilliant silvery white metal is extraordinarily scarce. Unlike gold, rhodium is almost never mined on its own. Instead, it is recovered in tiny quantities while processing platinum and nickel ores. Worldwide production is astonishingly small, typically less than 30 metric tons each year. That scarcity alone would make rhodium valuable. But its true importance lies in modern technology. Rhodium is one of the most effective catalysts ever discovered for reducing harmful vehicle emissions. Inside catalytic converters, it transforms dangerous nitrogen oxides into harmless nitrogen and oxygen, helping millions of vehicles meet increasingly strict environmental standards. No practical substitute matches its efficiency. Beyond the automotive industry, rhodium is prized for its incredible resistance to corrosion, outstanding reflectivity, and ability to withstand extreme temperatures. It protects jewelry with brilliant white finishes, enhances precision optical instruments, and serves critical roles in specialized industrial equipment. Because new supplies are so limited, recycling old catalytic converters has become one of the world's primary sources of rhodium. Its price is famously volatile. During periods of strong demand and limited supply, rhodium has traded for more than $29,000 per ounce, sometimes reaching values many times higher than gold. Its market rises and falls dramatically, but one fact remains constant. Modern civilization depends on this rare metal in ways few people ever realize. Rhodium isn't simply expensive because it's rare, it's valuable because our technology and our environment needs it. And that's what truly places it at the top of today's countdown. Gold may have built kingdoms, but these remarkable substances reveal that value comes in many forms. Some preserve human health, some expand scientific knowledge, others make modern technology possible. Together, they remind us that Earth's greatest treasures aren't always the ones that shine the brightest. They're often the ones working quietly behind the scenes to shape our future. If you enjoyed today's countdown, be sure to like the video, subscribe to the channel, and share it with someone who loves science and incredible discoveries. Thanks for watching, and we'll see you in the next video.